Welcome to Crash Course AP Physics 1. This is Unit 2 and we are on the second topic of Unit 2, Gravitational Force. Let's get started. The first topic is Newton's law of universal gravitation. So every particle in the universe exerts an attractive force on every other particle, and this particle size should be very small enough that we can consider it as a point mass. For two particles that have masses m1 and m2, and these are separated, like this is point mass, this is point mass, and they are separated, the distance between them is r, then the force is directly proportional to mass, to the masses product, and inversely proportional to the distance between them, the square of distance between them. And when we remove the proportionality constant, we get a constant capital G. This capital G is known as universal gravitation constant, whose value find out ultimately to be 6.674 into 10 to the power minus 11 Newton meter square per kg square. Next topic is weight and mass. So mass is the measure of how much matter is present in the body, that we know as mass. We measure it in the kg or gram. Okay, and weight we measure in Newton. So it is basically weight is the force, the gravitational force. So weight on planet Earth is the measure with what force Earth is pulling us. The weight of an object on or above the Earth is the gravitational force that the Earth exerts on the object. The weight always acts downwards. So if there is any object, it should be acting downwards towards the center of the earth. On or above another astronomical body, the weight is the gravitational force on the body by that body. So if instead of earth there is another planet, what force is putting that planet on the object, that would be the weight of that body or that planet. The SI unit of weight is Newton. So weight is equal to, this is the gravitational formula, force is equal to G into m1 m2 upon r square. R is the distance between these two. So if we consider this is our earth and this is the object is of mass small m, then there would be the force of attraction between them. So that force is represented as weight. Weight is equal to capital G. When we are on the earth, calculating for earth, this is the mass of earth and r is the distance between the earth and the point object. When we substitute this value, we get a value known as small g. This small g is known as acceleration due to gravity, and the value of it is 9.8 meter per second square, or sometimes for the ease of calculation we take it as 10 meter per second square. Now let's solve some of the numericals. A 5 kg object is released from the rest near the surface of the planet such that its gravitational field is considered to be constant. The mass of the planet is unknown. After 2 seconds, the object has fallen 30 meter. In 2 seconds, the distance covered is 30 meter. Air resistance is considered to be negligible. What is the gravitational force exerts on 5 kg object near the planet's surface? So what is the force or what is the weight we have to find of the object? So in this case, the planet is not Earth. So we cannot use G value as 9.8. Instead, to solve it, we have kinematic equation, constant acceleration, kinematic equations. So I am using second equation, which is s is equal to ut plus half at square. Because the initial velocity is 0, it would be 0. The distance is 30 meter, half. Acceleration we don't know and we have to calculate. This is basically g for the planet. And time is 2 seconds, 2 square. So 30 into 2 divided by 2 into 2 is equal to the gravitational pull on the planet. So it is 15. Just substitute in this value. So we know that force is equal to mass into g of planet. Mass of the object is 5 kg and g is 15. So we get it as 75 Newton. Another question, the mass of the planet is 1/10 of that of Earth. If we say the mass of the Earth is me, the mass of the planet is 1/10 of mass of the Earth. And its diameter is half of that of Earth. Let's say the diameter of Earth is dE, so the diameter of the planet is half of the dE. So we have to find the acceleration due to gravity of the planet. So we know that g is equal to small g is equal to capital G into mass divided by the radius, the square. So diameter is given, from this we can find the radius, just the half of it. So I can write that radius of the planet is equal to half of the radius of the Earth, right? Both sides divided by 2. And substitute, because we know the Earth's gravity is equal to gme upon re. R is the radius of Earth square. This is for Earth, and for the planet it would be gp is equal to capital G into mass of planet divided by the radius of the planet square. Now just substitute the mass of the planet and the radius of the planet in terms of Earth. So gp is equal to capital G into 1 upon 10 me divided by 1 upon 4 re square. So these terms, so I can write g acceleration due to gravity of the planet is equal to these all terms would make ge, and 1 upon 10 into 4. So gravitational acceleration of the planet is equal to 4 upon 10 into ge. We know that acceleration due to gravity of Earth is equal to 9.8. Just substitute this value. So we get gp as 4 into 9.8 divided by 10. So solving it, we get 3.92 meter per second square. Fourth is the correct option. If you like my videos, please like it, comment it, and subscribe my channel for the next update. And if you want any tuition needs for AP Physics 1, 2, Physics C, E&M, and Mechanics, then you can contact me through this scanner or email me on postera.physics@gmail.com. Thank you and see you in the next video.